Assalamu alaikum students, welcome to my YouTube channel Physics Tutor. And today we will discuss about the equilibrium, what is equilibrium and its types and all kinds. Basically, and the book says that equilibrium in physics, the condition of a system when neither its state of motion nor its internal energy state tend to change with time. A sample A simple mechanical body is said to be equilibrium if it experiences neither linear acceleration nor angular acceleration, unless it is disturbed by an outside force. It will be continue it that condition indefinitely. For a single particle, equilibrium arises if the vector sum of all forces acting upon the particle is u. A or rigid body by definition of distinguished from a particle in having the property of extension is considered to be in equilibrium if in a condition to the state listed for the particle above, the vector sum of the torque acting on the equal body 0. So that is the state of relation motion remains constant and equilibrium is said to be stable if small externally induced displacement from that state produce forces that tend to oppose the displacement and retain the body or equilibrium. Ex- an equilibrium is said to be stable if small externally induced displacement from that state produce force that tend to oppose the displacement and return the body or particle to the equilibrium state. For example, including a weight suspended by a spring or a brick lying on a level surface. An equilibrium is unstable if the least departure produce forces that tend to increase the displacement. An example is a ball bearing balance on the edge of a razor blade. In thermodynamics, the concept of equilibrium extended to the include possible changes in the internal state of a system, as characterized by its temperature, pressure, density, and any other quantities needed to specify the state completely. At strict thermodynamic equilibrium, the temperature of the system is uniform, and any gradient in state functions such as a pressure or a density are balanced by external forces so that they remain constant. For example, the equilibrium pressure at the bottom of the column of air is higher than at the top because of the force of gravity, and density gradients in a centrifuge are balanced by the centrifugal force. It is also useful to consider the quasi-equilibrium process where, for example, temperature gradients and allowed if rate of heat flow is too slow to be significant, but the system is otherwise in local thermodynamic equilibrium. For example, the adiabatic expansion of rising column of air account for the decrease of atmospheric pressure with altitude. Next is the equivalence principle, fundamental law of physics that state that the gravitational and gravitational forces are a similar nature and offer indistinguishable. In the Newtonian form, it's asserted in effect that within a window less laboratory freely falling in uniform gravitational field, experiment would be unaware that the laboratory is the state of the non-uniform motion. All dynamical experiments yield the same result as obtained in an inertial state of uniform motion and affected by gravity. This was confirmed to the high degree of precision by the experimental conducted by the Hungarian physicist Roland Otto's. In Einstein version, the principle asserts that a free fall affect the gravity, the totally abolished in the all possible experiment and general relativity reduce the special relativity as inertial state. Okay. Next topic is the torque and conservative force. It is also in the equilibrium state, and in next lectures we will discuss about the some other forces and other topics. Hope you will be understand. In this lecture we have studied all about the equilibrium and equilibrium states. In the next lecture we will discuss about some other types and other condition of some other topics. Hope you will be understand and goodbye, Allah Hafiz. We will meet in the next lecture.